Welcome to the battery management system for EV vehicle along with fire protection. And in this one we have added the extra feature like regenerative braking system to the system. So this regenerative braking system will provide us the power supply, the generator power supply whenever the brake applied to this wheel. So when we are reading the wheel, this is going to be directly vehicle movement wheel, and when we apply the brake to this, the motion of this wheel will be stops. Automatically the friction will be given as input to these wheels. Means these are the attached wheels to the inner wheel, and then these wheel attached to these dynamos. So there we are using the 12 volt 1 amp generators. We are using two. These two are in series. So the generator voltage will be added V1 plus V2, and that is the input to this battery pack through this charging circuits. And whenever the battery pack voltage is low, then automatically the generator voltage will be given back to our battery pack. Means here we are running this wheel mechanically directly when the vehicle moves, and then when you apply the brake, the generator voltage from the generators is input to the battery pack through this charging circuit. So here we are using this charging circuits which can be recharged through the generation section. And also the previous model as like same, using this transformer to the grid, we can charge this battery pack based on the low battery voltage alerts. We can select the normal charging or fast charging, and these two buttons will control these two electromagnetic relays to provide the power supply which is getting from this charging circuit. And here a main power supply we are providing when we are charging the battery pack on system monitoring through this grid. So the grid will provide us the 230 volts input to this transformer, and the transformer will step down the 230 volts AC to 12 volts of AC, and the AC will be converted into the pulsating DC. As we can see, the 4 diodes are presented on the charging circuit, and the 4 diodes will act as a bridge rectifier, and from there the pulsating DC is output to the input of capacitor which will act as a filter, and the filter will remove the pulses, and it will provide us a pure DC of 12 volts. The 12 volts is parallelly given to this battery pack through this electromagnetic relays, and parallelly to the 7805 voltage regulator which will take 12 volts DC input and provide us the 5 volts DC outputs. That is the operating voltage of our whole electronic components. So parallelly we are distributing that to the Arduino and remaining other components. And the major components are like transformer, regulator power supply which will act as a charging circuits, as well as regulator power supply, and electromagnetic relay boards, selection switch, normal charging mode and fast charging mode. And the next buzzer, whenever the low voltage or high temperature or fire detected, this will be identified that and provide us the alerts to the buzzer. And LCD display which is used to display the status of the project, means the available voltage, the battery pack, and also SOC SOH calculation. SOC nothing but state of charging. So like we have already predefinedly stored the time of charging for the battery pack to be get full, and while charging that it will keep on measuring the voltage of the battery pack. If the voltage is reached in certain time to the certain extent, then that is going to be the 100% of SOC. Or else if the charging time is more, if the battery voltage is not increased in the meantime, then the SOC will be decreased to 90%, 80%, like that. Same for SOH, state of health. So whenever we calculate the load to this battery pack, if the battery voltage is rapidly discharging, then the threshold value in threshold time, then the same SOH values will be decreased from 100 to 90, 80. Based on that, we can know the battery performance by seeing the SOC and SOH values on the LCD screen. And this is a load which will acting as a DC motor for the EV vehicles. And the same here we can observe there is a switch to on off the load, and this is the same charging circuit with rectifier and filter and 2 diodes along with LED indication. 2 diodes is which will block the current flow from the battery pack to the dynamos of this regenerating braking system. And there is a fan. Whenever the temperature or fire occurred automatically, then this fan gets switched on, then it will be trying to cooling the battery pack system. And this one is a current sensor to measure the battery voltage, to measure the current which is happen on this DC generator, DC motor. And this one is a voltage sensor which is used to measure the battery voltage levels. And this was a transistor board to on and off the CPU this cooling fan whenever the temperature increased. And this was the Arduino Uno board, main circuit of brain of a all kit. So let us see the demonstration. So let us see the battery management system along with SOC SOH calculations along with the fire protection initially, then we'll show you the demonstration directly to the regenerative braking system. Right. So as of now, the battery voltage is, so it will take around 5 to 6 seconds to calculate the SOC SOH values. As of now, the battery voltage is 11.5 H. So everything is normal, it seems, and temperature also 28. So okay, 26 degrees. So when it crosses the 43 degrees centigrade, then automatically the fan will get switched on. So you can see that now. And now the SOC SOH values are properly connected and calculated. Right. You can see that the buzzer got switched on as well as fan also got switched on. When the temperature is coming to normal, fan will be off and buzzer will be off state. Right. And the next, coming to the voltage. Just I am going to isolate the voltage sensor inputs from the battery pack so that it will provide us only 0 volts. That is indication of low voltage. When the battery voltage is less than 8 volts, then low battery voltage, you can switch it on. Just go to the fast charging. Right, fast charging message displayed on the LCD screen, and we can see the 2 relays got switched on. And when it is normal, battery levels come to the normal levels, then automatically these relays will be switched off and everything seems to be okay now. And next again, for coming to the normal charging. Right, it's normal charging message displayed, and same thing. Right. And whenever we on it again, battery voltage will be displayed. Right. Okay. And coming to the current, just we switch on this. As we are using the 200 milliamps of load we are using, so we can know the. Right. It is the start. You can just restart the system. Right. And also we can see the 200 milliamps of current consumed by this load. Right. And now coming to the regenerative braking system. Now, right, connect this over here. It's a 2-pin input and parallelly connected to the battery pack. And now just you can see the LED indication on the charge circuit. Here we can observe that. Right. Okay. Once again. Right. Okay. You can see the charging indication from this LED on the charge circuits. So when we press this, these 2 wheels attached to the inside of the drum, then automatically the brake friction will be applied, and parallelly the friction will be converted into the mechanical energy, and from there the mechanical energy will be converted into the electrical energy with the help of this dynamos.